In this video, we're going to learn how to determine experimental probability of an event. Now, experimental probability is calculated using a very similar equation to our theoretical probability. So experimental probability is entirely based on the data of an experiment. So the probability of whatever your event is going to be the number of successes in your experiment divided by the number of total trials. So instead of having the number of favorable outcomes over the total, we're now going to do the number of successes over the total number of trials that take place. So let's look at a couple of different applications of this. First, if we look at this first example, it says a mini golf course offers a free game to people who get a hole-in-one on the last hole. Last week, 44 out of 256 golfers got a hole-in-one. Find the probability of you making a hole-in-one on the last hole. So this is considered experimental probability because we're dealing with data that we gathered. So the probability of a hole-in-one is calculated by taking the number of successes, which is 44, divided by the total number of trials, which is 256. Now, as I look at this fraction, I notice that it does simplify. These are both divisible by 4, and if I divide both by 4, I find that my experimental probability is 11 over 64. Now, if I look at this next example here, it says you interviewed 45 randomly chosen students for the newspaper. Of those students, 15 of them play sports. What is the probability of the next student you choose playing a sport? So again, we're doing experimental probability because we're using data that we've gathered. And here we're looking for the probability that the next student we pick plays a sport. So again, we take our number of successes, which is 15, over the total number of trials, which is 45. And then we can simplify this fraction by dividing each by 15 to find that my probability is 1/3. Now, another way that you might see experimental probability displayed is in a table of values. So let's say that we performed an experiment where we flipped a coin. So let's say we performed this experiment. So let's say when we flipped our coin, we tallied the number of heads that we flipped and the number of tails. Now, I know that the theoretic probability of, flipping a head here would be 1/2 because it would be one head over 2 total outcomes. But when we're dealing with an experiment, we're going to use the data that we've gathered. So let's say that as we flipped our coins, we flipped a total of 54 heads. And we flipped a total of 46 tails. So this wasn't the perfect 50-50 split we expected, but given our situation, let's calculate the probability, the experimental probability, that we flipped a heads. So here, the probability that we flipped a heads is the total number of successes, which is 54. And then we divide by the total. Now remember, the total here is all of the flips that we had added together. So if we take 54 plus 46, I find that I had a total of 100 total flips. So I had 54 successful flips out of 100 total flips. Now if I simplify this, I find that my experimental probability simplifies down to 27 over 50.